Okay, year 11, just a quick YouTube on just to perhaps reinforce some of the stuff we did in class today on this long division. I know you really enjoyed that, going back in time and digging up some of the old horror shows of primary school. I know you didn't like my method down here of long division, but hopefully you've got sort of the hang of it. I've only given you one question for homework, and that's this one here, exercise 7b, page 215, 1a. What I thought I'd do is I'd do 1b, and then, you know, if you're having a little trouble with 1a, then you can have a look at what I've done with 1b with another example, and that might help. In fact, no, that's a dumb idea. How about I do 1a, but you do it first. So pause this video, go and do question 1a, which is, if you can't be bothered getting your book out, we're doing this long division here. Remember, what ultimately the reason we're doing this is so that we can factorize cubic polynomials, which before the onset of this piece of material we had no method by which we could do that. So we're dividing x minus x cubed plus x squared minus 2x plus 3 by x minus 1. This is question 1a, so I don't want you to write this down from my notes, because then you haven't done any work yourself. I want you to attempt this now yourself. Go and do this in your book, and then I want you to come back and press play again, and we'll see if we're getting the same stuff, if we're getting the same result. Right, so pause now. Right, welcome back. Now this is what I reckon. So what I'm gonna do is I'm gonna up top here, I'm gonna put down the term that, when multiplied through by x minus 1, will eliminate my x cubed. So that's going to be x squared. X squared times x minus 1, that's x cubed minus x squared. Alright, and now subtract. X cube's gone, beautiful. X squared minus x squared. That's 2x squared. And I'll bring down my minus 2x plus 3 as well. So what I've done there is this times this now is equal to this, and I've subtracted this from this, and I'm left with that there. Nice and straightforward. Now my 2x squared is my focus. I'm going to multiply by plus 2x. 2x times gets rid of my 2x squared, minus 2x is there. I do a subtraction, gone, minus 2x minus 2x. I feel like, have I done that right? Yep, so that's gone, and we're just left with 3. So my result is therefore x cubed plus x squared minus 2x plus 3 divided by x minus 1, just bracket those, is equal to x squared plus 2x with a remainder of 3. So I write that remainder as plus 3 over x minus 1. So there's my remainder of 3. Let's have a look at another way of finding that remainder. We talked in class today about substituting a value for x in, and if we get 0, remember, if you subbed in a value of x, you guessed value. If you got 0, you'd found a factor. Well, what we can do is we can find that's in effect a remainder of 0. If you divide a term by a factor, you get a remainder of 0. So when we substitute, in this case we'll substitute x equals 1 in here. We're not going to get 0, because we don't get a 0 remainder, we get a 3 remainder. So we should get a 3 remainder. So let's just check that. So I'm going to substitute. Now this is new work. So substitute x equals 1 into x cubed plus x squared minus 2x plus 3. Let's do that. So the reason I've chosen x equals 1 is because that's the division. I've divided by x minus 1. And the theory here is that if I divide by x minus 1, my remainder will be whatever I get when I substitute x equals 1 into the polynomial, the cubic polynomial. So if I substitute, I get 1 cubed plus 1 squared minus 2 times 1 plus 3. That's equal to 1 plus 1 minus 2 plus 3, which equals 3. Look at that. So I get 3. So this is actually known as the remainder theorem, which is a fairly obvious title. for such a thing. The remainder theorem will deliver the remainder. So the remainder when a polynomial, let's call this polynomial px. The remainder when a polynomial px is divided by x minus k will be pk. I don't know if that makes any sense at all. Let's just read that through again. Hopefully we'll see how it relates to what we've just done. The remainder theorem. The remainder, which is this thing here, this is what's left over once you divide it through. The remainder when you divide through by x minus 1, when you divide this polynomial, x cubic polynomial x minus 1 is 3. Now, this is saying, the remainder theorem is saying that the remainder when a polynomial, px, which in this case is that cubic, is divided by x minus k, in this case x minus 1, will be pk. This just means, this is for x minus 1, this is p1. So this is saying when you substitute 1 for x into the polynomial, you'll get the remainder, which is what we did here. That's the remainder theorem. If we get 0 for the remainder, then we found ourselves a factor. Okay, so we're going to move on to the remainder theorem when we get when we're in class tomorrow. So 1a you've done. Hopefully you got that okay. It's there and you've checked that out. There's no need to do anything more tonight other than just take these notes on the remainder theorem. I will give you some time tomorrow to do some more of these division questions. So some more of exercise 7b, and we'll also do some 7c from the work requirements. So it'll be pretty much just a work lesson. Have a good night. I'll see you tomorrow.